In this video, we will solve a problem on how to derive the profit function, total revenue function, the level of output which maximizes total profit, and the selling price at maximum profit. This question I got from the Facebook. The question is, a manufacturer producing X items per week has this average cost function, that is 1 upon 3x square minus 8.5x plus 50 plus 90 upon x. X denotes the output. The demand function for this product is also being given as 22 minus p is equal to 0.5x. P denotes the selling price. We have to find out the total cost function, total revenue function, profit function, level of output which maximizes the total profit, and the maximum profit and selling price at maximum profit. Okay, so let's take it one by one. So we have, first we need to find out the total cost function. Okay, so what is our average cost function? Average cost function is 1 upon 3 x square minus 8.5 x plus 50 plus 90 upon x. This is our average cost function. Now to get total cost function, total cost is simply equal to average cost times output. Okay, so when you multiply average cost with output, you get total cost. So this is our average cost. This is 1 upon 3 x square minus 8.5 x plus 50 plus 90 upon x. To this we multiply the output, which is x. Here solving, we will get total cost is equal to x into x is x cube, so we will get 1 upon 3 x cube minus 8.5 x into x is x square, plus we have 50 into x is 50 x, plus here we have 90x upon x, so x and x will get cancelled, so we only get here 90. This will be our total cost function. Coming to the next, that is to find out the total revenue function. Okay, so second part is to find out the total revenue function. Now you know that total revenue is equal to price into quantity, which is your output. So first we need to find, this is our demand function, we need to solve it for p. Okay, so to get the price function, then we will multiply it by x. So we have 22 minus p is equal to 0.5x. We will solve this for p. So if I transpose p to the RHS, so I will get p is equal to, and transposing this 0.5x to this side, so we will get 22 minus 0.5x. Okay, I have just manipulated this and solved for p. It's very simple, you can do this. This is our price function, what we call the inverse demand function also. Then our total revenue will be equal to price into output. So this is our price function, 22 minus 0.5x. To this we multiply the x. Okay, price into output, which gives us 22 into x is 22x minus 0.5 x into x is x square. So this will be our total revenue function. Okay, so then we have the third part tells us to find the profit function. Okay, profit is simply equal to total revenue minus total cost. So we got the two things here. Total revenue is 22x minus 0.5x square. Okay, this is our total revenue function. To this we subtract the total cost, and we have calculated total cost as this. This is our total cost here, and this is let me write it here. It is x square upon 3. So then we have plus 8.5 x square. Here it is cube, sorry. Okay, so x into x is x cube. Then it will become minus, then we have minus 50x, then we have minus 90. Okay, solving, so this will become 22x minus 50x, this comes out to be 28x minus 0.5 x square plus 8.5 x square. It will become when we subtract 0.5 from this 8.5, so we will get only plus 8, only 8x square. Okay, then we have minus x cube upon 3, then we have minus 90. This will be our profit function. Okay, so this is our profit function. Next question is the next part is to find out the level of output which maximizes total profit. Okay, level of output which maximizes total profit. So fourth part is, I guess, yes, it is fourth part. Now profit maximization requires our marginal revenue should be equal to marginal cost. This is first order condition, what we call first order condition. And second order condition is, let me write it here, second order condition requires that the slope of the marginal cost function at the critical points which we will get from this MR is equal to MC condition should be rising. Okay, so let's do it one by one. So first thing is to equate marginal revenue with marginal cost. So we need to find out the marginal revenue. Marginal revenue is simply the derivative of total revenue. Let's denote it T or prime. That means the derivative of total revenue function with respect to X. So what will be our marginal revenue then? Marginal revenue, okay, this is our total revenue. So derivative of X is 1. So we are left with 22 minus derivative of x square is 2x, so 2 into 0.5 will become 1, so we will be left with only x. Okay, and what will be our marginal cost? So marginal cost is simply the derivative of total cost function. I am, for the sake of space, denoting the partial derivative of total cost function with respect to x by tc prime. Okay, so this is our total cost function. This actually, now derivative of x cube will become 3x square. 3 and 3 will get cancelled. We are left with x square minus derivative of x square is 2x, so 2 into 8.5 becomes, this is 17x. Derivative of x is 1, so we are left with 50 only. Okay, then we equate these two. So we have x square minus 17x plus 50 is equal to 22 minus x. Okay, solving it further, so it will become, which implies our x square, transposing this here, it will become plus x. So minus 17x plus x comes out to be minus 16x. Then we have 22, transposing here, it will be subtracted with 50, so it will become plus 28, should be equal to 0. So we have quadratic equation here. Now we need to solve this quadratic function. For that, let me rub this out here. Okay, so we can factor it also, factor out also here. Okay, so we have x square minus, so minus 16x can be written as minus 14x minus 2x plus, in place of 28 I can write 14 into 2 is equal to 0. Taking x common in the first two terms, we are left with x minus 14, and taking minus 2 common in the last two terms, we are left with x minus 14 should be equal to 0. So it means either x minus 2 is equal to 0 or x minus 14 is equal to 0. I am just skipping some steps, you know it very well. How did I, how do we solve the quadratic type equation? So x is equal to 2 or x is equal to 14. Okay, so we got two output levels here. That means we got two critical pointers. Okay, so we need to find out which of these two pointers actually maximizes our profit. Okay, so first order condition was to equate marginal revenue with marginal cost. When we equated marginal revenue, with marginal cost, we got the value of output. Actually we got the two values for the output, that is x is equal to 2 and x is equal to 14. But to be sure which of these rather maximizes our profit, we need to check the second order condition. Second order condition tells us the slope of the marginal cost function at critical points should be positive. Okay, so second order condition tells us slope of marginal cost function at critical points should be rising. Okay, since we got two critical points, we need to see which of these actually satisfies our condition, at which point the slope of the marginal cost function is rising. Okay, so it would have been better if I can draw the graph to make it you know more meaningful, and I will do. So let's try to graph this out. So we have here, let us say x denotes the output on the horizontal axis, sorry, and price is denoted on vertical axis. Let us draw our average revenue function. Let us say this is our average revenue function. Then we have marginal revenue function. Its slope will be the twice the slope of average revenue function. So this is our marginal revenue function. Then we have marginal cost function. Okay, so we have a quadratic type. It will look like this. Okay, let us say this is our marginal cost function. So first order condition requires marginal revenue should intersect marginal cost, that is marginal revenue should be equal to marginal cost. When we solved, we got 2 points, x is equal to 2 and x is equal to 14. Okay, so corresponding to this, we have x is equal to 2 here, and here we have x is equal to 14. This was the first order condition. We can see a 2 points marginal revenue intersects marginal cost at x is equal to 2 and x is equal to 14. This was first order condition. Second order condition requires that at the intersection of marginal revenue and marginal cost function, the marginal cost must be rising. Okay, so let us see at which point the marginal cost is rising. Marginal cost rising means the slope of marginal cost at critical points should be positive. Okay, by slope we mean the derivative of marginal cost function should be positive. Okay, so that means derivative of marginal cost function, so that is dmc upon dx at critical points should be positive. So let's first figure out the slope of this marginal cost function. So we have derivative of x square is 2x, so we get 2x minus derivative of x is 1, we get only 17 here. Now evaluate it at critical points. Okay, when x is equal to, we calculated it somewhere. Okay, so we got 2 pointers. When x is equal to 2, let us see what will be our slope. So we have 2 into 2 minus 17, 2 2s are 4 minus 17, it will be a negative number, so slope will be negative here. So this cannot be our equilibrium point or profit maximizing point. Let's take another point when x was 14, when we calculated it. So when x was 14, so when x is equal to 14, our slope of marginal cost function at critical point will be 2 into the value of, this is 14 minus 17, so this is 2 into 14 is 28 minus 17, it will be a positive number. So we can see here, when x is equal to 14, marginal revenue is equal to marginal cost, and marginal cost function is rising at this point. Here also we have marginal revenue intersects the marginal cost, but the slope of the marginal cost function was falling. Okay, so the two conditions for profit maximization were that marginal revenue should be equal to marginal cost. Okay, and second order condition is the marginal cost should be rising at the intersection of marginal revenue and marginal cost function. Okay, so this was about the fourth part. Now we need to find out. So fourth part will be that when x is equal to 14, profit is maximized. Okay, coming to the last part, we need to find out the maximum profit. Okay, so then maximum profit will be equal to, just plug the value of x is equal to 14 into profit function. Okay, this is our profit function, so just plug maximum profit will be 8 when x is equal to 14. Okay, so just plug, let me write it here, 28 into 14 minus 8 into 14 square minus 14 cube upon 3 minus 19. Just plug, sorry, evaluate it, you will get the maximum profit is something 167. Okay, I'm not sure about the calculations, I have done it 2 times, I am not sure whether you will also get 167. It will be rounded off figure. And what will be the selling price at profit maximizing point? Okay, when x is equal to 14, corresponding to this, we will get the selling price. Okay, so selling price will be when x is equal to 14, go straight to the average revenue function. So our average revenue function is this, that is 22 minus p is equal to 0.5. The value of x is 14, so we will get okay, so this is 22 minus p is equal to 7, or p is equal to 22 minus 7, which comes out to be it will come out to be 15. Yes, it will come out to be 15. So our maximum, sorry, selling price, profit maximizing price will be 15. Okay, this was one way you can solve it. Another way is you can just use the profit function. Okay, so that means the two conditions will be there. First order condition will require the derivative of profit function with respect to output should be equal to 0. Okay, same condition, you will get x is equal to 4, sorry, x is equal to 2, or x is equal to 14. Then second order condition for profit maximization requires the second derivative of profit function with respect to x at critical points, at critical points should be positive. Okay, so you can use this very notation also to check the profit maximizing condition and second order condition. Okay, so what was our profit function? So our profit function was, okay, I don't remember what was here. Okay, I leave it for you people to check it. Okay, I hope I make myself clear. Thank you.